All right, what up, guys? We got Euler's number, classwork. Let's get going. So the key here, Euler's number E, anytime you see the word continuously with a percentage, you're going to be using that letter E. And that's the first step here to this growth factor. We have to have E raised to the R, but we do have to remember that R is equal to that 12%, which is 12 over 100, which is 0.12. Again, the trick is move the decimal over 2 times to the left, 1, 2, to get that 0.12. But the growth factor is E to the R, E to the 0.12. Please note, I didn't ask for any decimals at all in this situation. So technically you can leave it at E to the 0.12 if you prefer, or you could actually type out that E to the 0.12. You just kind of decide where you'd like it. I'm going to leave it like that for now because it's an exact answer and I like exact answers. For letter B here, assuming that the palm tree is currently 5 feet tall, creating a function with the input of years past and output of height of the palm tree. The idea is your input as time is going to have an output with the initial value of 5 multiplied by the growth factor to the power of time. That's pretty much it. Boom, we're done. How tall will the palm tree be in a decade? Well, a decade, that means 10 years. So we got f of 10 is equal to 5 multiplied by e to the 0.12 to the 10th. But now, even though this is an exact answer, we're now talking about a real world problem where you're trying to want to know how tall is this tree actually going to be. So we should be plugging it in. Desmos does this great. Desmos understands the letter E, so you'll be able to get the answer from Desmos directly. The other option is just to use your calculator. I'm going to show you how to use that calculator if you would like to. The idea here, the calculator will have the E button right there above the LN. So you're going to hit the second button on your calculator, the second button, and then the LN button to get that E right there. So it's going to be 5 multiplied by, we got that E to the 0.12, and we're multiplying that 0.12 times 10. And you get 16.6. And that's a good number of decimal places for this particular problem. One of my students was asking me, just a little extra thing, how to convert that into feet and inches. What you would do is you'd actually subtract the 16 away to leave just the remaining fraction left over, and you're going to multiply that answer by 12, and that will give you exactly how many inches are in that situation. So 7.21 looks like for the number of inches. Anyways, the bacteria in a petri dish grow at a continuous rate of 420% per day. What is the daily growth factor for this situation? So again, we got to do that R first. We got 420 divided by 100, which is 4.2, and our growth factor is E to the R, and the reason why is, again, that continuous percentage rate, which is E to the 4.2. And again, I don't really like multiplying out when I don't have to. The hourly growth rate. This requires us to remember one of our rules from a previous lesson, and that is when you have a growth factor and you want to change the growth factor, you're either going to be multiplying some more or unmultiplying, and to unmultiply is a little bit different. It's not really dividing. That's like one way of getting rid of the multiplication, but it's a version of division with the exponent getting the division. So the hourly growth factor, there are 24 hours in a day, and because there are 24 hours in a day, we're going to take the 4.2 and divide by 24. Another way of thinking about it is e to the 4.2, which is that growth factor, and you're raising it to the 1 over 24 power. You're dividing it into 24 separate situations, because if you multiplied it 24 times, you'd get back up to this one. So I don't know how you want to think about it, but either way, hourly growth factors is divide by 24 on the exponent. Be careful when you're typing into the calculator. Make sure it all ends up in that exponent up there. Assuming the petri dish begins with 100 micrograms, that's how you say that. It's a mu, the Greek letter mu, and it stands for micro. So 100 micrograms of bacteria. Create an equation with input of time passed and output of micrograms of bacteria in the petri dish. So we got f of t, same idea as before, starting with the initial value, multiplied by the growth factor, and it's input of time passed. So I didn't really tell you if it could be hours or in days. So either one of these numbers is fine. for that guy to the power T. How many micrograms of bacteria at the petri dish would be in 6 hours? So in this case, we got f of 6 is going to be 100 multiplied by e to the 4.2 divided by 24 to the power of 6. Plugging all that into the calculator, we got 100. Sorry if you were writing that, my bad. 100 multiplied by e to the 4.2 divided by 24. And I forgot my parentheses. To the power of 6. We get, looks like 285.765 for that final answer. So 285.765 micrograms. I always have struggles with those mu's. They look like U's, but they have like that straight line on it. So you gotta like, I don't know, whatever. All right. Either way, all done. That's how many bacteria are in that situation. So here we go. Polonium 210 decays continuously at a rate of 2% per 138 days. That is a real number. That is how it works with polonium. So the growth factor, because it has the word decay, that means the R value is negative. So R in this case is negative 2%, and that's going to be negative 2 over 100 or negative 0.02. And again, we have to do e to that power. And that's our growth factor. The yearly decay factor. Now, this is a tough one. I did try to make it a little bit tougher right here at the end. So we have the 138 day. So if you have the 138 day, you can raise that and divide by 138. And if you divide by 138, it's going to bring you to the daily growth factor to get up to the year, 365 on top. And that's going to give you your yearly decay factor for this situation. And again, you don't have to multiply out. You can just leave it like that. And we want to create this equation with the 2.7 kilograms of polonium. So we're starting off at 2.7, multiplying by e to the negative 0.02 to the power of 365 divided by 138. And then all of that is getting raised to the t power. Do remember, all this can be multiplied together. So just a little note for yourself in a future class, you could technically rewrite this like this. 0.02 times 365 times t divided by 138. Like, all of that's the same. You don't need to do anything like that, but I'm just trying to let you know that you power, you multiply exponents. So you can type it in like this, like when you do your calculator. But for your calculator, you're plugging in after a year. So t is going to be 1. So you're doing f of 1. And when you do f of 1, I'm just going to plug it in the calculator. You're making that t equal to a 1. So we got 2.7 times, looks like e, what did I write over here? We got negative 0.02 times 365 times t, which is 1. Didn't even need to put it really, and divided by 138. What was the number there? Yes. And you get 2.56. Looks like, what is this in this? This is kilograms. So 2.561 kilograms of this polonium will remain. That's it, guys. Have a wonderful rest of your day, and peace out.